Example for chapter 10. A 1 meter cube rigid tank contains ammonia at state 1, temperature pressure and temperature ambient temperature. The tank is connected with a valve to a line as shown in the picture. Flowing saturated liquid, line flow, saturated liquid at the valve is open and the tank is charged quickly until the flow stops as the valve is closed. As the process happens very quickly, there is no heat transfer. Determine the final mass in the tank and the irreversibility in the process. Final mass or M2 and irreversibility. At first, we should determine the problem first. Control volume, tank, initial state, T1, P1. Now the inlet state, TIX. Now saturated liquid, process, adiabatic, no kinetic or potential energy change. Model, ammonia table. the first continuity m dm or m2 minus my1 equals to mi. Inlet minus outlet, the change in mass. From first law we have Q HI first law Q control value MI HI NEHE N2U2. The kinetic and potential energy change is 0 minus M1U1 plus W. Q and W is 0 MIHI MEHE we can have a relation for M2. HI minus U1 use the relation for M from the first law, and from the second law we have M2S2 the Q part for S generation, MIHI NEHE plus S star generation 0 0 So at first A, we should calculate what is M2. For the initial first state, temperature is 20 degrees centigrade 20p 200 kilopascal. For the state 1, we should check with the ammonia tables first. Add table B2, table B2 1. First check for T pressure, temperature, saturated temperature is about, so we have superheated vapor at state 1, table B 2, we can obtain these quantities for state 1. State I, saturated liquid at temperature table B2 1, HI, HF minus 10. And also SI, SF, you know that M1 it is observed that only the final pressure is known, so the one property is needed. The unknown are the final mass and the final internal in the equation for the m second that we obtained before. M1 we have two unknown, peak pressure to Pi, P saturated. Choose for this case we have P and or M2 on M1 we have a relation also M second is B on B2 and we have two options, two phase and superheat. At first we assume two-phase. If we obtain logical equality between 0 and 1, our assumption is true. For two-phase, M2 is V Vf at F3 at P equal to, we have these quantities for V, for M2, and for U so we have M2 on M1, Hi minus U1, He minus U2. We have all the relation. M2 is multiplied to M1, of obtaining Hi is now U1 also now H, this is Hi. Hi also U2. X2 from this relation we can obtain it X2 it is logical, and we can obtain another desired quantities. For example, V2 is and S2 meter cube on kilogram. M2 is V on V2 start generation. M2S2 minus M1S1 the irreversibility. Aim to also obtain it. You can also calculate U2 additive. This is not